plus 15. So this is what we have here. This is what we have here. So this is a first order differential equation. But this form, this question is of the form of separable differential equation, whereby this is your f of x, okay, and this is your y squared plus 1 is your g of y. So please remove this one from here, and that will be 1 over y squared plus 1 dy. Remove this dx from here, and that will be equal to what? 1 plus x all over what? X squared minus 8x plus 15 dx. So to this your integral sign there too. So what we now do now, let's start from the right hand side. If you check it now, the numerator is having power 1. The degree of the numerator is 1, and that of denominator is 2, and that will take us to partial fraction. Okay, so let's take that one out. 1 plus x, well, what? X squared minus 8x plus 15 is equal to what? That will be equal to, we need to factorize this one. Factorize the denominator. It's a quadratic expression. The factors of 15 that can generate minus 8, that will be what? Factors of 15, that will be 3 and 5, and that will be minus 3 minus 5. So we're going to have x minus 3 into bracket what? X minus 5. Okay? So then we are still on the right hand side. This one over this one will be equal to a over one of the linear factor plus b over the second linear factor, and that will be equal to this one times this one. That's a times x minus 5 plus b times x minus 3. Okay, and then equal to the what? The numerator on the other side. Actually, the denominator, by the time you do the algebra, cancel out. So this is what we have now. So what we need to do now, we need to get the constant value for a and b by substitution. Okay, so let our x be equal to 5. If you do that, this expression will cancel. Then we can get this one. So 5 minus 3, that's 2b. Okay, this one 5 also. 5 plus 1, that's 6. So b is what? B is 3. At the same time also, let's cancel b by making x to be what? Let x be equal to 3. So that will be 3 minus 5. That's minus 2a. And then here, that's 4. So a is what? A is a minus 2. So we've gotten the constants a and b. Okay? And the reason we are using the partial fraction, there is no direct table for this fraction. Okay, for this polynomial, there is no direct table. Okay, and what you have to check is that there are rules to do partial fractions. In this case now, the degree of the numerator in this place is less to the denominator, and that takes us to partial fraction. Okay, so please subscribe to the channel so that you can be able to forward your questions, make your comments. Okay, give me likes. Okay, let's go on to continuations of the solution. So then the next thing to do now is to come back here, come back to this place. Okay, so and that will be equal to the integral of this one, 1 over y squared plus 1 is arc tan y. Is arc tan y equal to this one is going to be integral of my a is what? My a is minus 2 over x minus 3 plus my b is what? My b is 3 over x minus 5. Close the brackets and dx. So this will be equal to, if you do the integral of sum of function will be integral of each of those functions. So this will be minus 2 natural logarithm of x minus 3 plus 3, the integral of 3 over x minus 5. Okay, the 3 can go outside the integral, so you are having integral of 1 over x minus 5. That's a natural logarithm x minus 5, and then plus what? Plus c up tan what? Up tan y. Okay, so that starts on these aspects. You divide both sides by what? By root y, and that will be 1 over this one. Okay, remove this dx from here. Okay, and that will be equal to what? 2 over 3 plus x. So that will be the x, and this is what? The y. And then introduce your integral sign. That's 1 over 3 plus x dx. Okay, then can you also do the algebra? Remove this 1 over, that's y to power minus half dy. Okay, and then 2 times what? 2 times integral of this. So on the final note, don't forget the formula for integration. So the power plus 1, that's what? This power minus half plus 1, that's half, over the power, okay, equal to 2. This one, this question is funny, but the rule is this. Integral of 1 over x is equal to ln x. Okay, so it doesn't matter whether you are adding or you are subtracting, whether you are adding or you are subtracting at the denominator. It doesn't matter. It will give you the same answer. So this will be natural logarithm of what? Of 3 plus x. Okay, whether you have integral of 1 over x plus 3 or 3 plus x, it will give you the same answer. Okay, to give you the same answer. So plus what? Plus the constant of integration. Then this is half, and you have 1 here. So this will become 2 times y to power half equal to 2 ln 3 plus x, and then plus c. So I think that starts on that question. If you like, you can remove this 2 from here, divide both sides by 2, and that will give you this particular equation. I'll give you this particular equation. So 2 will go from here, so that will be plus c over 2. So that starts on these separable differential equation. So if you look at this equation, you can see that we can pair this one together. We can also pair this one together. So from the numerator, 3 is x is common here. Take it out. So we have this. Here also, minus 1 is common. Take it out. You have this. And when you factorize, this and this must be the same thing. Do the same thing also for the denominator. X is common. Take it out. That's y minus 2. Here also, plus 4 is common. Take it out. And then you have this. Also, this and this must be equal when you factorize. And don't forget your dy dx. Okay, so after that, the next thing to do now is to take one of the common factor, one of these, and then x minus 1, over, do likewise at the denominator. That'll be that will give you this one. Then you now realize that you're having 2 functions. You have f of x, you have g of y. Okay, and this call for what? This call for us to separate the variable. This call for us to separate the variable, and the g of y is a fraction. So you are dividing both sides by this fraction. Okay, so by the time you do that, by the time this one leave this place, it's going to flip upside down, and that will be this by what? Y plus 3. I'm going to explain this one further. Don't forget your integral dy, and then remove this dx from here, and then you're having x minus 1 over x plus 4. Okay, close the brackets, dx, and then introduce your integral sign. This is what you have here. This is the fraction you have here. And then for you to remove this fraction from here, you need to divide by this function. So by the time it's coming here, it's going to be 1 over this fraction. and that's why it's flipping. It's flipping upside down. So this one, if you look at this numerator and denominator, the degree is equal to each other, and that will call for polynomial division. So we are going to apply polynomial division. The numerator is y minus 2. The denominator is y plus 3. Okay? So then when you are doing polynomial division, you take the first one here, and then you divide by what? The first one here. Okay? That's giving you, the first one is y. That's giving you 1. So you have 1 here. So that 1, you use it to multiply the what? The divisor, the denominator. So 1 times this one, that's y. 1 times a plus 3. So do your subtraction. After multiplication, you subtract this one minus this one, 0. Minus 2 minus plus 3, that's minus 5. So this is your remainder. This is your remainder. This is what will remain. This one is your quotient. This one is your divisor. So the integral for this one now will now become the quotient plus the remainder minus 5 over the divisor. That's y plus 3. Close the brackets. The what? The y. Okay. We're going to do the same thing for the other side also. For this function, apply your polynomial division. You have x minus 1, x plus 4. So do the same thing. This one over this, the first one. That's 1. So multiply as I did for the other one. So that will be what? 1 times this one, that's x. 1 times this one, that's a plus 4. Then do your subtraction. So it's going to give you minus 5 also. Okay. So permit me to clean this here. I've said that this is today is the day. So we're going to cover this. After this one, we're going to linear differential equation. I've said that differential equation, the first order differential equation, could be linear. Okay, they depend on the form you have, the format of the equation. We can have a separable differential equation. We can have a linear differential equation, and we can also have nonlinear differential equation. So after this one, we go to the next segment, which will be linear differential equation. So by just joining me, you're welcome on board. Keep typing your questions. I promise to respond to those questions. Okay, but now I cannot be doing 2 things at the same time. But I promise to respond to those questions. And if you have your own question, you are welcome. Put the question there. I'm going to make a live section for those your questions. Put your questions there. Okay, on those 3 segments: separable differential equation, linear differential equation, and Bernoulli differential equation. So let's quickly wrap it up for these particular questions. On the left side, we have this. If we've gotten this one, the plus minus, that's minus 5 over y plus 3. Close the brackets. And then the other one is going to be the same thing. That'll be integral of 1 minus 5 over x plus 4 dx. So that's what we have. You're welcome. Keep typing your question. Keep typing your questions. Keep typing. Okay. So this one we have now is natural logarithm of y plus 3. Okay, and then equal to x plus 5. Okay, this is minus. We have minus here. Natural logarithm of x plus 4 plus c. So that's what we have, and that's the final conclusion. To quickly recap it, the tools I use on here, this is integral of the 5 can come outside. This is 1 over what? Y plus 3 dy. Okay, the basis of this integration is just integral of 1 over y is what? Natural logarithm y. Okay, so if you're not adding anything to this function, it doesn't change the form of the answer. So that's that on this one. Same thing also for this one. Okay, so you're welcome again. Welcome again. Keep typing your questions. Type your questions. Type your comments. Okay, so that's that on these separable differential equation. and this is be the end of these segments of separable differential equation. The next thing we want to look into would be linear differential equation. Linear differential equation. Okay, let's go on. Let's go on. Let's go on. Welcome again. Welcome on board. Linear differential equation. How do you know it? Okay, don't forget linear, separable. They are all first order differential equation. So linear differential equation is of this form. It could be of this form. A subscript 1. You can use your dy dx, or I can use y prime plus a naught, a subscript 0 as a function of x, y, and equal to. This could be equal to, let me call it b of x for now. So this is the format you are going to have. Okay, but this can be transformed. This can be transformed to another form. Remove this one from here. This is the constant value. This a subscript 1, a subscript 0. They are constants. Okay, so this a subscript 1, use it to divide through the equation. So, and that will give you what? That will now remain what? Your first differential. Okay, and then plus a subscript 0 over a subscript 1 as a function of x, as a function of x. Okay, and what again? Don't forget your y there. Okay, and then equal to what? B of x over what? A 1. Okay, a subscript 1 as a function of x. So this is the format. If you have something of this nature, this is step to take. Final conclusion, your linear differential equation is of this form. This fraction could be what is called p of x. Okay, and this one also, this fraction, I can call it f of x, either f of x or q of x. So this is the general form for linear differential equation. This is the general form. Okay, without wasting time, without wasting time, the next thing to do, because it go beyond just talking, we need to practice question. The more question you practice, the faster you become. You become more perfect. Okay, and then your accuracy will be number 1. The more questions you solve, the better you become. Let's go to questions. Okay, on this linear differential equation. X dy dx minus 4y, x to the power 6 e to the power x. So if you look at this question, you can realize that it follows the first statement I made on linear differential equation. So this one has to remove from here. That's the first step. Okay, and that will be equal to what? Dy dx. Okay, equal to 4 over what? By x. So I'm dividing 2 by what? By x. And then y equal to what? This will be what? x5. Okay, so that's what we have. And this now conform to the standard table, standard format for linear differential equation. Okay, let's conform to the what? Where your p of x is equal to what? Minus 4 over x. The question to ask now, how do we solve, or what are the steps to be taken when solving linear differential equation? The first step is to get the integral factor, integrating factor. Get that. It has this symbol, mu. It's a function of x. So, and that will be equal to, it has this formula, e to power integral of what? P of x dx. And then we have value for that. This is p of x is what? The minus 4 can go outside. And then what we have 1 over x dx. And that will be equal to, integral of 1 over x is what? Is natural logarithm of x. And don't forget your minus 4. and that will be equal to what? And that will be equal to x to the power minus 4. I will buttress that. Okay. Anytime you have exponential e to power of lim of a function, okay, it's going to be what? It's going to be that function. It's going to be f of x. So that's that on that case. Okay. You can check the playlist on Math Sci Consults for the engineering playlist. Okay, it has become a course. You can check it for more detailed illustration on linear differential equation. Okay, so that's that on this question. We've gotten the first step, which is what? Integrating factor. Step 2, which is the final step, is to get the general equation. I'm using formula method to get the what? The general equation. And what is the formula? What is the formula? How does it look like? Let's go and see the formula. Okay, so the formula is this, which is we call it general solution. The general solution is going to be what? 1 over integral factor, 1 over integral factor as a function of x. Open your brackets, integral factor times your f of x, dx, then plus c. So that is the what? That is the general. That is the general. That is the general formula. That's the general solution. You get your integral factor, and then you generate the what? The solution of the equation. Okay, the general solution of the equation. So, what is your f of x now? Your f of x is this one. I know the moment you correlate it to the standard formula of linear differential equation, then you can get your what? F of x. So that's what we have in this case. Let's make implication. Let's substitute. Let's plug in f of x. Let's plug in the integral factor, and let's solve it. Don't forget, please, there is an integral sign here. Pardon me for that. There's an integral sign here. Okay? So, please keep welcome on board. Okay? For those that are new on the channel, please subscribe to the channel so that you can have the opportunity to type your questions. Okay? Subscribe right now. Okay? And if you are watching live now, please call your friends, call them to come on board. Okay? Put in your questions, put in your fresh question, and I promise to respond to it. If it's not possible on this at the moment now, I will make another live video for the solution to those questions. Okay, so this is what we have now. We've already gotten the integral factor, which is what? Which is x to the power minus 4, which I can also put your brackets, x to the power minus 4 times your f of x. Oh, I've cleaned the f of x. I think I can remember x5 ex. Okay, don't forget your integral sign, the x, then plus c equal to what? Equal to that. So that's what we have now. Then this one, x to the power minus 4 is 1 over x to the power 4, and there is 1 here. So this will become x to the power 4. Okay, open your brackets, and then this one, if you do the algebra, you're having 1 over this x to the power minus 4 is this. So times what? Times x to the power 5. So it remains 1 here. Ex dx integral sign plus what? Plus c. Okay, so that's what we have in this. That's what we have. Then the next thing to do now is to check this one out. Let's get the integral of this one. This one involves a product of two functions, and that call for integration by parts. Okay, whereby we can make u to be this. Okay, and then we get the u, the x. Okay, the u respect to this function will give you 1, and this will be equal to this. Okay, and then the v is equal to what? Is equal to this. Then integrate this, integrate this. So v is what? V is this. So then the formula I'm going to use is this is uv minus v integral of v du. So that's the formula for integration by parts, and that will be equal to don't forget what we have here. That's a that'll be equal to x to power 4. Open your brackets. uv, my u is this, is x. My v is this one, e to power x. Then minus integral of v. My v is what? Exponential to power x. And then the u is simple as what? The x. So that's what we have. On the final note, we're going to have this minus, if you integrate exponential function, it's going to give you that function back. But there are exceptions to that integration. Okay, you can check the playlist of calculus 2 or calculus 1. These have been explained in detail. Check those playlists and watch that. So that's that on this. So what you can do now for the general solution, if you like, you can open the brackets and get the answer. I skipped something here. Don't forget your plus C. So that's that on these linear differential equation. Let's see more questions. Let's see more questions. I've given the step to be taken. So let's follow those steps. Remove this one from here. Anything that attaches to the dy/dx, remove it from that place. So you divide the equation by what? By that attachment to your dy/dx. That will be equal to what? dy/dx is equal to what? Plus. This will be remain what? 3x plus 2 over x y equal to what? This will be s squared plus 1. So I divided through by what? By that attachment to my dy/dx. Okay? And I want to tell you, nothing happened by magic. I used to say that in my videos. Nothing happened by magic. You need to take your journal, take your pen, and begin to work along with the speaker. Okay? Take your pen, take your paper, begin to work along. The more you do that, at least you can get, possibly 40-50% assimilation. And after the class, after the video, you can also look at it again. Okay? Do it now. Take your paper, take your journal. Okay? Take your pen and begin to work along. Okay? With me. So this is what we have now. So what we are going to do now, this is linear. We can see your dy/dx, you can see your y here. So I'm going to bring them together. The y/dx is equal to what? Plus 2 over x y. Bring all the x function to one side, and that will be equal to what? S squared. Move this one to the other side. That's minus 3x and plus what? Plus 1. So these now conform to what? To the y first differential plus what? P of x y. Okay? Equal to what? F of x. Okay? So this conform to that. And that is the general format for linear differential equation. Okay? So what do we do next now? What do we do next? Welcome on board. This is engineering maths. Okay? This is engineering maths. And we are going to be looking at after this differential equation, we're going to look at the exact differential equation. How to know, we're going to look at that. We're going to do a Laplace theorem and lot of more. So a lot more on this episode. Okay, so this is what we have here. So that means if you correspond here to this standard form, your P of x is equal to what? Is equal to 2 over x. And you must know, don't forget that, there must not be any attachment to your dy/dx. There must not be any attachment to your dy/dx. So that's what we have in this case. That's what we have in this case. Then the next thing to do in solving linear differential equation is to get the integral factor. Okay, and that will be equal to what? That will be equal to e to the exponent p of x. My p of x is what? Is this, dx. And that will give you e to power 2 natural logarithm of x. And that will be equal to what? These two can come on top here, and that will be x to power 2. I think I've explained that in the previous examples, previous question. I will repeat myself again. It said that anytime you have e to power of lim natural logarithm of a function, it's going to give you the function. It's just that. Okay, that's that. It's going to give you this the function, and that's what we have applied. Okay, so that is the integral factor. Then the next thing to do now, we've gotten the integral factor, is to get the general solution. Get the general solution. Okay, get the general solution. The general solution, as I've said, is the general solution is going to be general solution as y is equal to 1 over integral factor, that's s squared, and then open your brackets, integral factor times this is your what? This is your f of x. They correspond to the standard form. That's your f of x. Okay, s squared minus 3x plus 1. Close your brackets, then dx, then plus c. That's your integral factor. That's your integral factor. Welcome on board. Welcome on board. Okay, welcome on board. Please subscribe to the channel so that you can have the opportunity to type your question. Type your question. Okay, you can have opportunity to also make comment. Also, type your question. Okay, and we are going to improve on that. Whatever comment you make, we'll work on that. Okay, so this is what we have now. Don't forget the integral sign here. Okay, welcome on board again. Please subscribe to the channel. Okay, subscribe now. Do it now. Don't make it tomorrow. Do it right now. So this is what we have now. So this is going to be x minus 2. You can remove this one over, and that will be equal to integral. Can you open these brackets? That will be x4. This one times this one minus what? X to power 3 plus x squared dx, and then plus c. Okay, so that's what we have. That's what we have. So that's what we have. Yeah. Click on the subscribe button. Do it now. Do it now. Okay. Do it now. So this is what we have. So on the final note, the general solution is going to be what? Integral of x to the power 4. Don't forget, when you are integrating, okay, you're integrating, it's going to be what? The function and the power plus 1 over the power and then plus what? Plus c. That is how to integrate. Let's apply that. So this will be x to the power 5 over 5, and then minus what? 3. The 3 plus 1 over 4. Okay, x4 over 4, then plus the power here is 2. So 2 plus 1, that's x3 over 3, and then plus what? Plus c. As simple as ABC. So that's that on this question. If you like, you can open the brackets and do the expansion. Okay, but there's no need for that. You can open the brackets. So that's the general solution for this question. Check it. And what this means is very simple. Just go to where we stop. This one means x is 1 when y is what? Y is 0. Plug in these two variables where we stop, and get your c. So once you get your C, go back to that equation and what? And write the value of C. Okay, so that starts on that question, that differential equation. Okay, so what we do in this case is very simple. As I said in the intro, this attachment to your dy dx must be removed from that place. Okay, and that would be what? Dy dx equal to what? The dy dx equal to what? Plus. This is what? 2x squared over x cubed equal to minus 6x what? X cubed. Okay, so this will be dy dx plus 2 times this will be this. Okay, equal to this one will give us minus 6 over what? Over x squared. Okay, so correspond this to the what? Standard standard form for linear differential equation. So whereby my p of x is equal to what? It's equal to this. Then get the integral factor as a function of x, which will be equal to what? It has this formula. P of x is what? 1 over x. You can take that 2 outside, and that will be equal to what? E to power what? Natural logarithm of x, and then times 2. And that will be equal to what? X squared. Welcome again. Welcome, welcome, welcome. Keep subscribing. Okay? Keep subscribing. Okay? Keep subscribing. Make it a butterfly effect. Share the links of this live video to your friends. Okay? So this is what we have. That's what we have for the integral factor. Then the next thing to do is to get the general solution. The general solution will be equal to what? 1 over integral factor. Okay, times integral factor. Integral times what? Times f of x is this one, which is minus 6 over x squared dx, and then plus c. So this will be equal to what? 1 over x squared times this one and this one will cancel. So we have integral dx. We can bring this minus 6 outside the integral, and then plus what? Plus c. So final conclusion, this is 1 over x squared times, open your brackets, times integral of dx is x, that minus 6x plus c. And that's that on this particular question. That's that on this particular question. Welcome once again. Welcome if you're new, just watching for the first time. If you're a returning subscriber, thank you for coming on board. Okay, please invite your friends, send the links to others. Okay, subscribe if you are yet to do so. Do so right now. Don't make it tomorrow. Do it right now. Okay, let's take more questions. Okay, let's take more questions. Still on linear differential equation. Linear differential equation. Still on linear differential equation. Let's look for more questions. Case, and we have the condition given. We have the condition given. So that's what we have in this case. Welcome on board. Welcome on board. If you're new, okay, if you're new on the channel, please smash the watermarks on the video. Okay, subscribe now. Subscribe now. Okay, do it now. Don't make it tomorrow, so that you can have the privilege to type your question. You can bring in a fresh question. I promise to respond to that. Okay, promise to make it another live video for you. But now I cannot do two things together, to comment, to respond to your questions now. Okay, well, after this section, I promise to respond whatever questions you have. So this is what we have now. We have the y dx cos x plus y sin x equal to this, and we have the condition given y as a function of 0 equals to 1. Okay, so let's see solution to this. In the intro, I've said that the attachment to your dy dx must be removed from that differential equation, from that first order differential equation. So divide through by cos x. So if you do that, we're going to have dy dx plus, this will be what? This will be sin x over cos x y, and then equal to, this one this is a double of cos. So that will be, it remain 1. This is cos square x over cos x. So that will be x cos x. So to remain 1. So then this now conform to the standard form for linear differential equation, whereby my p of x is equal to what? Is equal to sine x over what? Over cos x. So that's what we have here. Okay. So I'm going to come back again after I finish the linear differential equation. I'll give myself like 30 to an hour. Then I'll come back again for Bernoulli differential equation. Today is the day. Okay. So please forward the links to your friends and friends. Okay. Subscribe now so that I can forward your question. If you forward your question, if I come back, I'll bring those questions on live section and we'll solve it. Okay. This is engineering maths. Okay. This is purely engineering maths. Okay. So please, welcome once again. Subscribe. Do it right now. So this is what we have. This is my p of x. This is the p of x. This is the p of x. Then when the first order differential equation conform to what? To the linear differential equation, then the first step to be taken is to get the integral factor. Okay, get your integral factor. Get your integral factor, which has the formula of this. The formula is what? Sin x over cos x. Actually, sin x cos x, sin x over cos x is tan x. But I want to leave it in this form. Okay? You can use change of variable. I don't want to waste time there. This will be done in this way. This is what I will do. The derivative of the denominator, almost the same as the numerator. Almost. Derivative of denominator is minus sin x. But there's no minus at the numerator. So this is minus sin x. So it's as if I'm altering the numerator. Okay? In order not to make it as if I've changed the question, I'm going to inject negative outside. Okay? So this is just a bit manipulation. There's no magic there. Minus times minus is minus, is plus. So it come back to what? To the same format. So whenever the derivative of the denominator equal to numerator, it's going to give you ln of the what? Of the denominator. Okay, and don't forget the minus we have here. Okay, and that will be equal to what? Cos x to power what? Power minus 1, and that will give you 1 over cos is what? Is sec x. Okay. Once again, nothing happened by chance. You need to practice. Okay, the more you practice, the better you become. Okay, the more you practice, the faster you think. Okay, the more you practice, you become excellent. Okay, take your journal and begin to work along with me. Take your journal. Okay, take your pen, take your paper, begin to work along with me. This is what? Engineering maths, purely engineering maths, and we are solving first order differential equation. Okay, linear differential equation. So we've gotten the what? The integrating factor. One more step again is to get the general solution for this linear differential equation. Okay, let's get the general solution. The general solution is very simple. The general solution is 1 over integral factor, which is sec x. Open your brackets. Integral of what? The integral factor times times our f of x. I think I've claimed that the f of x is what? f of x, we check f of x is x cos x. So remember, okay, on the right hand side, initially we have x cos x all square, and then we divided by what? Cos x. So it remains this one. So times what? Times x cos x dx plus c. So that's what we have. Let's begin to break down. This is a complex trig function. Sec is one over cos. So if you now reciprocate sec now, it's going to give you cos x. If you do the inverse of inverse of sec, and don't forget sec is what? 1 over cos x. Put one on top, and give you this one. So you have cos x. Open your brackets. Then do the algebra for this one, which is integral of 1 over cos times x cos x. So this and this will cancel, dx plus what? Plus c. Okay. So and that will give us what? That will give us cos x. So we just have x dx in this place plus what? Plus c. So we have this plus c. Okay. So then on the final note, this will be equal to integral of this one. This is having power 1. So that will be x to 1. Don't forget the general formula for integration. The power plus 1, that's 2 over 2, and plus what? Plus c. So that's that on that. But that's not all. We're given a certain condition. We're given this condition that this one is equal to 1. Okay? Which means when x is 0, y is what? Y is 1. So that's the implication of this statement. Okay? When x is 0, y is 1. Okay? And the essence of this, okay, the reason behind this condition is for us to get the c, the constant of integration, okay, to get this value of c. Okay, so that's the reason for that. So in that case now, it's going to be y is equal to 1, cos 0 is 1. So that's 1 over, this one is gone. That's c. So c is 1. C is 1. So come back here and plug in your c. Come back here and plug in your c. So that's that on these linear differential equation. Questions still continue. Questions still continue on linear differential equation. If you are here for the first time, you are in the right place. I must tell you that. If you are here for the first time, you are in the right place. Okay? What do you need to do? It's not too much. Just what? Smash the subscribe button. Subscribe now. So that you can type your question, your own fresh question. And I promise to respond to your question in another live question section. Okay? I'll go for a break after this linear differential equation. If I see your question, I'll bring it live and we're going to solve it together. Okay, type your question. Okay, welcome on board. Begin to share the links of this live now. Share it to your friend, make it a multiplier effect. Okay, and then once again, okay, take your journal. Begin to work along with me. Okay, take your journal. So the moment you begin to work along with me, part of it will sink to your body. You get more understanding. But if you are looking, you're just joking, you are playing. But if you really need the business, take your paper, take your pen, and begin to follow along with me. Okay? Next question. Prime dy dx equal to what? P of x equal to what? Equal to P of x y equal to f of x. So if you correspond that, your P of x is equal to what? Your P of x is equal to minus 3. And then your f of x is what? Your f of x in this case is 0. Okay? So this is what we have now. Then we can get this, since this is linear differential equation, we can get the integral factor. The integral factor will be equal to what? E to power what? Integral p of x is what? Minus 3 dx. And that will be equal to what? E to power minus 3x. Then the general solution will be equal to what? 1 over integral factor. Okay, open your brackets. Integral factor times the what? The f of x, which is what? 0 dx plus c. So all this one we cancel. So you just have, in this case, just have this one. You can leave your that's a c. So that's general solution. Okay, and that will be equal to, if you remove this one over, so to negate, to cancel this minus here, so that will be what? E 3x times what? Times c. So, and that's the solution to this question. I want to appreciate you for watching the channel, for coming live. Okay, for watching me live. I think for the first time. Okay, and I promise to be coming regularly on live section. Okay, so you can send your question to my email, to the comment section. Okay, you can bring in a fresh question, and I promise to make it a live section for you. Okay, permit me to go for a break in the next few minutes, 30 to 1 hour. Let's make it in the next 1 hour. We'll come back again for live section of Bernoulli differential equation. Thank you once again. Okay, please subscribe. Do it now. Thank you. See you next section.